Hello, students! Let's do more practice problems for your homework set. Dun, 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 dun. This is 8th grade math, Unit 4, Lesson 9, practice problems for your homework set. And I'm now working on problem number 2, which, as you can see on your screen, there's a lot of information. Let's read through it together. Priya and Han are biking in the same direction on the same path. Han is riding at a constant speed of 16 miles per hour. Write an expression that shows how many miles Han has gone after T hours. Okay, so right away we're getting into it. So for A, it tells you that Han is riding at 16 miles per hour. Let's write that down. Han rides at 16 miles per hour. And an expression that shows how many miles he's ridden, I'm going to call that distance. So D equals distance. I'll spell it out once so that you don't get confused later. Distance that Han rides, I'm going to call that D with a subscript H, distance for Han. And that equals his speed, 16 miles per hour, multiplied by the number of hours he's been riding, which we're going to call T, because it says T hours right there. Go ahead and write that in your notes. T equals hours of riding. In this case, it's hours that Han has been riding. Okay, so A is finished. That was easy. I wrote an expression showing the distance that Han has traveled. I'm going to go ahead and use this expression really quickly because I want to make sure that you really feel this math. So on my next page here, I'm going to graph it. And on the y-axis is distance. And on my x-axis is time in hours. Let's go ahead and label our axes. You should always label your graphs. So on the x-axis, hours. On the y-axis, distance, which is in miles. Let me do it this way. Time in hours. There we go. And then here, distance in miles. That looks great, doesn't it? So Han starts at a time of 0 hours. So for him, his first dot is here. T equals 0, and his distance at that time also equals 0. He's at the origin. And after the first hour, he has gone 16 miles because his speed is 16. I'm just going to say every line here equals 5. So that's 5, 10, 15. So 16 is just above the 15, something like that. And then at 2 hours, he's gone 32 miles. So 15, there's 20, 25, 30. So at 2 hours, a 32 is right, I don't know, something like that. And let me just go all the way out to 3 hours. So 3 hours is 16 times 3. So that's 30, 42. Huh? Wait, I want to make sure I don't make a mistake. Sometimes when I do it in my head, I lose track. 3 hours times 16 miles per hour, a 48. My mistake. So 30, this is 35, 40, 45, and then this is 50. So 48 is just a little below there. I'm just estimating my points. There, at 3 hours, he's biked 48 miles. Pretty good biker, right? And I'll draw a straight line. This will work, this old piece of paper. Going from the origin. If I drew these points correctly, they'd all line up together, but that's okay, I'm just sketching it. Okay, this is for Han, and you'll see why I did that later. That might help us understand the problem. And here's an equation that represents the graph. When you show his distance versus time on a graph, here's the equation, here's the graph. Okay. B. Let's keep going. B. It says, Priya started riding a half hour before Han. Priya wakes up early. If Han has been riding for T hours, how long has Priya been riding? Oh, okay. Well, so T is for Han then? Is that T Han? Then Priya's time, I'll call that T of Priya. That is equal to however long Han has been riding plus 0.5 because she got up half an hour earlier. Whatever his time is, she's already been riding for 30 minutes more, half an hour. So 0.5 H, 0.5 hours. Okay, here it is. Here's my answer for B. Let's keep going. Question C. Priya is riding at a constant speed of 12 miles per hour. Just a second, I'm going to write that down because that's given information. Priya's speed is 12 miles per hour. Okay, got it. Write an expression that shows how many miles Priya has gone after Han has been riding for T hours. So actually Priya's time is different than Han's time, but we're using Han's time in the expression. It says after Han has been riding for T hours. Okay, we can do that. So we're writing an expression for the distance that Priya has gone according to the time that Han has been riding. Got it. Well, then how much time has Priya been riding? We figured that out in part B. So the distance that Priya has rode her bicycle is equal to her speed times the time that Priya has been riding. Oops, I want to use a lowercase. And this time that Priya has been riding is right up here. So let's substitute that in. And we get 12 times the time that Han has been riding plus half an hour. Okay, and here's my answer. Here's the expression for the distance that Priya has gone. And I'm going to graph this now. Wait, before I graph it, I should simplify it. Don't you think? We have these parentheses. I'm going to use the distributive property and simplify this. So remember, when you have a number outside of parentheses, you need to multiply it through the terms in parentheses. We're going to distribute it. So 12 times t is 12t plus 12 times 0.5. Well, 0.5 means 1/2. So 12 times 0.5 means half of 12. That's 6. And then let's stop a second. Does this equation make sense? It's saying that the distance Priya has traveled is 12 times how many hours it's been plus the 6 miles that she traveled before Han even started. So when t equals 0, just remember when t equals 0, that's when Han started riding, but she had already been riding for half an hour. During that half an hour, she went 6 miles. That makes sense because Priya's speed is 12 miles per hour. So in half an hour, she can go 6 miles. Now I want to graph this. I want to graph this equation right here. And what it says is that Priya has traveled 6 miles and then she continues riding at 12 miles per hour. So our graph starts at 6 for Priya. At time equals 0, Priya's already gone 6 miles. And then after 1 more hour, she's gone 12 miles plus, just a second. I don't want to do the math in my head in case I might lose you. So let me draw this out. The distance that Priya has traveled, always make a data table if you're not sure where the numbers come from. So at 0 hours, Priya has already gone 6 miles. After 1 hour, she's gone 12. plus 6, because t equals 1. 1 times 12 is 12. So 12 plus 6, she's gone 18 miles after 1 hour. After 2 hours, now I'll write this one out. After 2 hours, put in t equals 2, and you get 12 times 2 plus 6 equals 24 plus 6, and that equals 30. So after 2 hours, Priya has biked 30 miles. Okay, how about after, I don't know, how about after 4 hours of biking? Then we're going to substitute t equals 4, and we get 12 times 4 plus 6 equals 48 plus 6, which is 54. Ooh, that's really far. Let's graph these points and then compare the distance that Priya has traveled. So at time equals 0, Priya's traveled 6 miles already. Not traveled, but rode her bicycle, I mean. At time equals 1 hour, Priya has gone 18 miles. So that's like, oh, right below the 20 here, like that. At 2 hours, she's gone 30 miles. So that's right here. You know what? I need to use a different color. Otherwise, I'll never figure this out when I want to draw my line. Here, and here, and here. The blue dots are Priya's dots. Okay, and then at 4, she's gone 54. So let me get that up here. 1, 2, 3, 4, right below the 55. Here we go. Okay, and I'll connect the lines. Okay, let me zoom in a little because this part's pretty important. Okay, take a look closely. You see that Han, who started 30 minutes later but is biking faster, he's behind Priya until about 2 hours. And then about 2 hours of biking, he catches up to her. She had already gone 6 miles when he started, but he passes her. And where does he pass her? Where does he catch her? It's where these 2 lines intersect. Now look closely. At that point on the graph where these 2 lines intersect, they have the same time, which I'm just estimating looks like 2 hours if my graph is drawn okay. At 2 hours, they meet, and that's about 30 miles. So I can see these 2 numbers here, they mean something. That's where they're meeting at. Let's get back to work. Okay, so I graphed the distance that Priya has traveled over time, and I graphed the distance that Han has traveled over time. Let me get back to the questions now. D says, use your expressions to find when Han and Priya meet. Now, I knew they were going to ask that, so I really wanted to show you these graphs. They didn't ask you to graph it, but seeing the graphs might help you understand what these numbers and expressions mean. Now, if you had not graphed that at all, what would you do? Let me show you what you might do for D. Remember that the distance Priya has traveled, we simplified it, and it is 12t plus 6. You have that in your notes. I didn't make that up. We did that together. You saw where I got that. And the distance that Han has traveled was 16 times t. I'm just going to write it down again. Now, when do Han and Priya meet? It's when they've gone the same distance. Then Han passes Priya. It's at the same distance and it happens at the same time, of course, because they're not time travelers. So set these 2 equations equal. 12t plus 6 equals 16t. That means the distance that Priya has traveled equals the distance that Han has traveled. I'll clarify that. The distance that Priya has traveled is equal to the distance that Han has traveled. Now, solve for t. They're not time travelers, so you know they're both there at the same time. Okay, how do we solve for t? We need to combine like terms, so I'm going to subtract 12t from both sides of the equation. And when I do, this 12t cancels out, and then I get 6 equals 16 minus 12t, 4t. And then I'm going to divide both sides of the equation by 4. And then this 4 divided by 4 becomes 1, because 4 divided by 4 is 1, and I get 6 divided by 4 equals t. Well, I'm just going to reduce this fraction at the same time. That's 3 over 2 equals t. Did you see what I did? I just reduced that fraction. Anyway, I'm pretty good with fractions, and 3 over 2, I know that equals 1.5. So what we see is that after 1.5 hours, they cross paths. And I don't know what distance that is yet, though. We're going to solve that next. Now, when I graphed it, I thought it was about 2 hours, right? But I didn't really draw my graph perfectly. Now I want to double check things. If I've solved this correctly, then I can substitute t equals 1.5 back into both Han's equation and Priya's equation, and they're going to give me the same distance. So let's do it. So the distance that Han has traveled, and I'm just using this equation right here, and I'm going to put in t equals 1.5. Oops, that's Priya. I'm sorry. Here's Han. So that's 16 times, the time is 1.5 hours. What is 16 times 1.5? Well, half of 16 is 8, so it's 24. 16 times 1.5, I said, is 24. See? 24. And then the distance that Priya has traveled is 12t plus 6, 12, and the t is 1.5, plus 6. 12 times 1.5 is 18. I'll just double check myself. 12 times 1.5 equals 18, right? 18 plus 6 is 24. There. Ding! Look at that, 24 and 24. The distance that Han has traveled after 1.5 hours is 24 miles. The distance that Priya has traveled after 1.5 hours is 24 miles. So I did it correctly. This is correct. It makes sense. Okay, I'm going to change the numbers in this problem. Priya's speed and Han's speed are going to be different because you have to really do the math yourself and then check your answer in order to get the problem right. I hope you took notes carefully, but if you didn't, please watch the video again, taking notes carefully. See you later.